Namaste friends, welcome back to Pavi Tech Zone. In this video, we are going to discuss about computing paradigms and we will see how each paradigms work and why they are so important. So let's get started. Ever wondered how massive amounts of data are processed simultaneously across the globe? How do your online services stay smooth even when millions of users are connected at the same time? The answer lies in the fascinating world of computing paradigms. But what exactly are these paradigms and how do they differ from one another? Why do we need different approaches to handle various computational tasks? Today we are going to break down 5 key computing paradigms that are essential in the modern digital landscape. Those are parallel, distributed, cluster, grid, and cloud computing. Whether you are streaming a video, conducting complex scientific research, or simply searching the web, these paradigms play a crucial role in how data is processed and delivered. Each one offers unique advantages depending on the task at hand. Parallel computing, it is all about performing multiple calculations at once. Distributed computing spreads tasks across the multiple systems, and cluster computing combines the power of multiple machines to work as one. Grid computing leverages geographically dispersed resources, and cloud computing, where the resources are provided as a service through the internet. By the end of this video, you will have a clear understanding how each paradigm works and why they are so important in the today's technology driven world. So let's dive in and explore these paradigms. So starting with the parallel computing is a type of computation where many calculations or processes are carried out simultaneously. So in the parallel computing, all the tasks or any process is carried out simultaneously, as if you have any one big task, it is reduced into small tasks and all tasks are run in the simultaneous way. Instead of solving a problem step by step in a single sequence, parallel computing breaks the problem into smaller tasks that can be processed at the same time across multiple processors. So instead of solving the problem one by one, parallel computing take all the tasks in a parallel way and complete the given task, where the single task is distributed among multiple processes and they are executed in the parallel way and they achieve the goal. This is particularly useful in scenarios where speed and efficiency are crucial, such as scientific research, real-time data processing, and advanced gaming. So let us take a real-world example. Imagine you are playing a highly detailed video game. The game engine needs to render complex graphics, simulate realistic physics, and manage AI for multiple characters at once. If these tasks were handled sequentially, the game would lag and become unplayable. However, with parallel computing, these tasks are divided among multiple processors, allowing the game to run smoothly in real time. Another example is scientific simulations, such as weather forecasting or molecular modeling, where massive data sets must be processed rapidly to produce accurate results. So as we take example of the game PUBG, so it is a huge gaming which requires high quality features and high processing speed. So as it is a big game, so you can't run the actions one by one. They all must be executed in a parallel way where the user can play the game efficiently. So if you are executing one by one, you could not play the game. So they must be executed in the parallel way so that user can play the game in more optimized way. So as you can see its diagram where we have three processors to execute the given task where all three processors share the same memory. The same memory is given to the processor 1 and same memory is given to processor 2 and same memory is given to processor 3. All these three tasks run on the same memory, but they execute the different tasks. Processor 1 runs the different task, processor 2 runs the different task, and processor 3 runs the different task, but they all three use the same memory. The primary benefit of parallel computing is speed. By dividing a large task into smaller simultaneous tasks, you can achieve result much faster than with traditional sequence computing. As compared to the sequence computing, parallel computing is more efficient and faster. Next, we have distributed computing. Distributed computing is a model where a task is divided among multiple computers that communicate and collaborate over a network to complete the task. In distributed computing, a task is divided among multiple computers. So, if you have any task to perform, it is divided among multiple computers to complete a task. Unlike parallel computing, which typically involves multiple processors within a single machine, distributed computing spreads the workload across the multiple independent machines, often located in the different geographical locations. So, as in parallel computing, where the single task was given separately for multiple processors in the same machine, but in distributed computing, a single task is distributed among multiple independent computers. So as you can see the difference, in the parallel computing, the single task was divided among multiple processors in the same device, but in distributed computing, single task is divided among multiple independent computers. So this method is highly effective for large scale problems that requires extensive resources. Let me take a real world example. One of the most common examples of distributed computing is the internet itself. Search like Google search, social media platforms, and streaming services rely on distributed computing to manage vast amount of data and serve millions of users simultaneously. Another example is distributed databases, which stores data across multiple servers to ensure that the system remains operational even if one or more servers fail. So as the single task is divided among multiple independent computers, so if any one of the computers fail to perform the task, all other computers will take care of that task. So there is no problem if one computer fails to achieve the task. So as you can see the diagram, it is one independent computer, it is one independent computer, it is one independent computer. All these three are performing to achieve the task. So this computer has different processor and different memory. This computer has different processor and different memory. This computer has different processor and different memory. If computer 1 fails to execute the task, computer 2 or computer 3 will achieve that task. So the task is divided among multiple independent computers. The key benefit of distributed computing includes scalability and fault tolerance. By spreading the workload across multiple systems, distributed computing allows for easier scaling as the demand increases. Additionally, because the system is decentralized, there are less chances of failures. If one machine goes down, another takes over its workload, ensuring continuous operations. So there is no pause or stop in the operations. If one computer fails, and another computers will take care of the operations. Next, we have cluster computing. Cluster computing involves connecting multiple computers known as nodes into a single system. These nodes work together to perform tasks as if they were one unified machine. Unlike distributed computing, where each computer can be geographically dispersed, Cluster computing typically involves machines located in the same physical space, often within a data center. So, cluster computing involves connecting multiple computers together to perform tasks. These all machines must be located in the same physical space. As we seen in the distributed computing, where computers can be placed in any geographical locations, they were connected each other. But in cluster computing, they must be located in the same physical space. So as you can see here, machines located in the same physical space. The goal is to enhance the computing power and improve the reliability of the system. So let me take a real world example. So if we take HPC, high performance computing clusters are prime example. These clusters are used in research institutions and complex simulations. Companies also use clusters to handle large scale data processing tasks such as financial modeling and big data analytics. So as you can see here, the main computer, which is called root node, is connected with the multiple computers which are called slave node. They all are connected each other, where all three are located in the same physical space. The location of the all computers are same. They are connected each other to perform the task. The main benefits of the cluster computing are high availability and cost effectiveness. Clusters offers redundancy. If one node fails, another take over, ensuring continuous operation without significant downtime. So, if any one of the computer fails to execute the task, another two will take care of that task. So, there is no any chances of fail in the operation. Next, we have grid computing. Grid computing is a form of distributed computing where resources from multiple independent systems are combined to work on a single task. Unlike cluster computing, where nodes are usually located in the close proximity, grid computing leverages geographically dispersed resources that may belong to different organizations. So as you can see here, grid computing is a part of distributed computing. As distributed computing says that the task is divided among multiple independent computers, and grid computing will combine these computers to work on a single task. So as cluster computing says that all the computers must be in the same location, but in the grid computing it is not in that case. You can have the computers in the different geographical locations, and it combines the multiple computers to work on a single task. The key idea is to tap into the unused computing power across various locations to perform large-scale tasks. And real-world example for grid computing. A well-known example of grid computing is the large-scale scientific research projects. So, where grid computing is used to process vast amounts of data generated by the experiments. So, in the case of science, where the scientists will be working on a project, if there are scientists who are working from different geographical locations, they all can get connected and they all can work on one single task, and they can easily process their high quality data which is generated by their systems. So where grid computing easily helps to combine the multiple computers to work on a single task. So as you can see its diagram, where user get connected to the multiple computers through the grid server, and he get connected to the grid client with the help of the network, where all the multiple computers get connected each other and they work on the single task. Grid computing major benefits is to include resources sharing and collaboration. By pooling resources from different locations, grid computing allows for efficient utilizations of computing power that might otherwise go unused. making it ideal for collaborative projects. So the main motive of the grid computing is to utilizing the resources from all locations required to complete the given task. Otherwise, these resources may get unused. So making them all used to achieve the given task. So where it says that efficient utilization of computing powers, where you can use all the resources from all locations to achieve the given task in the more efficient way. And next we have cloud computing. Cloud computing is a paradigm where computing resources such as servers, storage, and applications are delivered over the internet as a service. Unlike traditional computing models where resources are owned and managed locally, cloud computing allows users to access and pay for only the resources they need on demand. This flexibility has made cloud computing an integral part of the modern IT infrastructure. So the user can get the resources or any storage or any application related services through the cloud with the help of internet. He can only pay for the resources which he use. So as we look on traditional computing, where if you wanted any resources to complete your task, let's say if you want any of the resources, you must pay completely for it to get the access. But in case of cloud computing, you can pay only the amount, you can only pay for the resources which you are using. So you can easily demand the cloud based on your requirements. So real world example for cloud computing uh, includes cloud computing platforms like Amazon Web Services, which is AWS, Google Cloud, and Microsoft Azure. These platforms provide a wide range of services from data storage to machine learning, all accessible through the internet. Businesses use cloud computing to scale their operations quickly, host applications, and store massive amounts of data without the need to invest in physical infrastructure. Like if you are running any big business where you deal with the big data, you need huge amount of space to store that data. In that cases, you need some big storage facility to store your data. In such cases, cloud computing helps to store this data in the cloud. So it would take huge amount to store that data in physical format. So it will be easy to store the data in the cloud where you can easily pay for only storage of the data. If you need any other resources like any operating systems or any server related resources, you can easily buy it from the cloud on demand, paying for the resources only which you are in need. So there are some platforms where like Amazon Web Services, Google Cloud, and Microsoft Azure, where they provide all these services to the users on pay per use method. So as you can see its diagram, where user can easily get the resources on demanding to the server, and cloud computing has broad network access and where it provides multiple resources for the users like storage, operating system, any hardware, database, etc. and measured services where user can easily access the services on by paying only which they are in need. The primary benefits of the cloud computing are flexibility and scalability. Organizations can easily scale resources up or down on demand, reducing cost and improving efficiency. Additionally, the cloud computing allows for global accessibility as services can be accessed from anywhere with an internet connection. So, the main feature of the cloud computing is where you can easily scale up or down the resources whenever if required. Like example, sometimes you may need huge database to store the data and sometimes you may require it in less amount. So you can easily scale up the resources according to your needs and you can access the resources wherever you want with the help of internet. If you have the internet connection, you can easily access the resources wherever you want and whenever you are in need. So in this video, we have explored the 5 key computing paradigms: parallel, distributed, cluster, grid, and cloud computing. Each of these paradigms offers unique advantages tailored to different computing needs, from speeding up complex calculations to enabling global scale collaboration and flexibility. Understanding these paradigms is crucial in today's technology-driven world, where computing power is backbone of countless industries and innovations. So in the next sessions, we will be coming up with the multiple concepts of cloud computing. So if you found this video helpful, please give it a thumbs up and subscribe our channel for more tech insights and leave a comment with your questions or topics you would like to cover us in the next sessions. Don't forget to subscribe my channel. Thank you.